morning, guys. I'd like to take a few minutes here and show you the importance of our HPP program. I want to give a little bit of a demonstration of a small part of what we do on the service. I wanted to get right down to the guts of it so you guys would see exactly what happens once we do just a simple coil cleaning on the unit. So as you can see, I've already got my gauges hooked up to it to give us our pressures. I've got my amp probe hooked up to it on the high voltage side to give it the exact power consumption. As you can see right now, nothing's running and it's reading at 0. So we'll take a couple of baseline readings. The first thing we'll do is go inside and turn on the unit. You will see the pressure rise on the high side and drop on the low side. We'll go inside and take a temperature of the air coming in and the air coming out to see how much of what we call a temperature drop or split we're going to get. All right, let's go inside. All right, I'm now over at the thermostat, and what I'm going to do is switch it to cool. And I'm going to drop the temperature down pretty low to about 68 degrees. That's only so it'll stay on and continue to run while we're making the test. So the first thing I'll do is start off with my temperature tester. This is a laser thermometer, so I don't have to climb up on any ladders. I just simply shoot it, and at the red dot it will tell me the temperature. Looks like right now we have a return air temperature of air going in of about 77 degrees. So we'll now go into another vent. Remember, this is where the air is sucking in. It's called the return air. It will then be drawn into the unit in the attic and run through an A coil and cool down. So now we'll walk in here and take a couple of readings and see how much our air conditioner is cooling down the air. Remember, it was 77 in. And now it's dropped to about 68 degrees. So we're cooling down pretty well. That's about a 9-degree drop. So now we'll go back outside, take our base readings on the unit itself, and see what we have. To start off with, we'll have a look and see what the amperage reading is. It's 12.57, so that means it's pulling about 12 amps, 12.5 amps, close to 13 amps. This is what is representative of the power that it's using that in turn spins your electric meter. The lower we can keep this, the less your meter spins and the less money you spend operating. As you can see, our pressures are about 150 on the high side and about 65, 66 on the low side. The pressures seem okay, but again, we'll see if we can lower this, because if we can lower this pressure by cleaning these coils, it will also lower the power consumption that it's using. Okay, so we're 1262, we're 150, and 65. Okay. All right, our next step is to spray some condenser cleaner on the unit. This is a very high grade of cleaner that's only available through a refrigeration wholesaler. It's something that the homeowner cannot get. It's very strong and very concentrated. And so initially what we'll do is we'll be spraying this condenser coil. And what this will do then is it will start tending to lift all the dirt and dust out of that, because the cleaner we can get this, the more efficient the unit will run. And that's what it's all about. You can see it immediately begin to work, and the foaming action, it will start lifting out the dirt and dust and oils and whatever that's accumulated. Just like on your automobiles, you know that our Las Vegas air is not the cleanest in the world. Alright, our chemical is set on for about 10 minutes now. It's done its work. The next thing we're going to do then is make sure we completely rinse all of it out. Otherwise it will do more harm than good, because it will gum up. So what you need to do that is a sprayer. Preferably it will have a flat pattern on it. The pressure that comes out is also critical. you don't want any more than about 30 psi. Any more than that will literally bend the fins over and do more damage again than we can repair. So 30 psi and more of a spin spray pattern, and I'm just going to rinse everything out very good. All right, our cleaning is complete. I've put my gauges back over here where they were originally, where we can see them. My amp probe is back on. Again, it's reading 0 at the moment because the unit isn't running. Before I did this, I killed the power. I killed the high voltage because, as we all know, electricity and water don't mix. Okay, our unit is started back up. As you can see, we dropped our baseline. We were at 12.5 on the amps. Now we're about what, Dave? 11.24, 11.25.
Right.
Our pressure over here we want to have a look at is now changed from 150 to closer to 140 pounds. So as you can see, just the cleaning alone has helped everything out. It's lowered our amp draw. It's lowered our pressure, just as I told you it would. And the other advantage is it will lower the amount of power you use from Nevada Energy. Now we'll take a look inside, see what our temperature drop is now. Before we were going in at 77, I believe, and coming out at 68. I wrote it down just to make sure. We'll go in and see what it is now. Yes, that's exactly what it was. 77 in, 68 out with a 9-degree drop. We'll now walk in and see if that made any difference in the temperature. Now we're back on the inside of the house. The first thing we'll do is exactly what we did the other time when we got our baseline readings. We're going to take a shot of the return air, and we find out that it has dropped a little bit now. Now we're at about 74 degrees. So in just a short period we've been running it, it's already dropped the temperature of the space about 3 degrees, 3 or 4 degrees. Our original baseline reading when we started was 77 degrees return and a 68 degree supply or discharge air temperature measured from this very vent. We've now done our simple coil cleaning with the proper chemical, the proper hose, and the proper method. So anything improvement we get in this, we can deduce solely to the coil cleaning. Here's our discharge air temperature reading now of 60 degrees. So you can see now we have lowered the discharge air temperature just by simply cleaning it. So now with a 74 degree return and a supply temperature of 60 degrees, we now have a 14 degree temperature drop rather than a 9 from what we had. So we've improved it by almost 50%. Again, that's what we do on the HPPs, and that's why we stress how valuable it is. And that's why no customer should be without it. All right. Thank you for your time, guys.